Hey everyone, welcome to the third YouTube video in English. Thank you very much for all the support that you have done until today. Subscribe if you're interested to see videos related to segment routing, to SRv6, to service provider, security or data center. Feel free to subscribe and I will keep uploading videos every week. So this time I have a very interesting feature for you related to our previous video that was segment routing manual policing. So we created in the previous videos explicit paths based on labels. This time we will do two things. We will also see how to create explicit paths based on addressing, right? Because if you remember the previous video, we created an SRT, as I said, based on labels. So we saw how to create an explicit path using manual policy based on the labeling, either adjacency seed or prefix seed. This time we will also see how to create explicit paths based on addressing, but this is not our main interesting feature for today. Our main interesting feature for today is called wait ECMP, right? So what does it mean? Is basically the way that we can do load balancing in segment routing traffic engineering when we have two paths for reaching out the same destination, right? So it's a way that we could load balance the traffic across the core for reaching out one specific destination. So this is the method of doing load balancing for the policies in segment routing traffic engineering. So if you remember our previous video here, we had this CE2, right? That CE2 had the loopback 0 with the 200/32. This was running BGP as a BGP PCE protocol, P2C protocol, with the P2. This is not P1, this is P2. So he was sending the prefix to P2, right? P2 was forwarding the prefix towards the raw reflector because, as we used it this lab before, the PEs has a VPN before session with the raw reflector, right? So P2 was forwarding this prefix 200 that he received from C2 to the raw reflector, and also we saw that there was a color assigned there, that this was the color 100, right? So this color was assigned as part of the SRT policies. If you want to know for what is the use of this color in BGP and in SRT, better if you check out the first YouTube video that I have done, because there I explain, and the previous video as well, because there I explain for what this color attribute, extended attribute in BGP means and what is the use case for that. But I will just explain quickly here. So this prefix was attached when P2 received the prefix from CCIE2, he basically redistributed the prefix into VPN before and assigned the color 100 in the BGP update, right? So this was sent to a raw reflector. The raw reflector reflect towards the P1. The P1 was in the prefix 200/32 with the color 100, right? In the BGP update. So P1, it was seeing this prefix with this color, and P1 was configured with an SRT policy saying that whatever prefix that is colored with 100 and that the endpoint is the loopback of P2, meaning 2222, right? 2222, whatever prefix that is colored with 100 and is pointing to the loopback of P2, basically, we saw and we configured in the previous video that it will follow the manual policy, or more or less explicit path, going through P1 to provider 1 and provider 1 to P2. We did this based on explicit path with labels, right? So this was the path that we defined for all the traffic that goes to the prefix that are received with the color 100. In our example, the prefix was the 200/32. So this was what we have done in the previous video, right? Now, how this fits into wait ECMP? Well, wait ECMP is basically, as I said, to distribute the traffic for the services. In this case, the service is the prefix 200 because this pertains to the user, so it's a VPN service, to split the traffic towards that specific service across different paths in the core, right? So this is a purpose of wait ECMP, is to load balance the traffic across the core for the particular service. And how we can do that? How we can basically distribute the traffic. Let's say P1 will say, I want to send the traffic to provider 1 and to provider 2 for this particular service. Obviously, I cannot do based on the service IP prefix, but I need to do based on the endpoint, because the next hop for reaching this service specifically is P2. P2 is basically advertising the loopback, the prefix for the VPN user into route reflector, this prefix 200/32. And when P1 receives this prefix, the next hop for that prefix is the loopback 0 of P2, right? So what we can do for load balancing the traffic for this service is basically to create two paths pointing to the same destination. One path can follow the traffic upper that will go through P1 to provider 1 and then to provider H2, and the other path can go downstream to provider, from provider H1 to provider 2 and then to provider H2. So we can have two paths going upper and down, right, for the same destination, right? Once we have those two paths pointing to the same destination, then we can distribute the traffic load for that particular next hop. And this means that every prefix that we receive from that particular router, the traffic will be distributed across these two paths, right? In a nutshell, that's it what weight ECMP means in SRT. Basically, we have two paths in the core going through the upper layer, that is P1 to provider 1, then to PH2, and the second path from P1 to provider 2 to provider H2. So that's the essence of weighted ECMP. Sometimes I like to compare this feature with class-based weighted FARQ. If you have seen QoS, probably if you are preparing for CCNA, CCNP, or CCIE, you for sure have been seeing this class-based weighted FARQ, and this exactly is the same. It's based on weights, right? Weights across the different classes. You assign the percentage or the bandwidth that you want across different classes, and this is being used based on demand, right? So in SRT, this is kind of similar because it's weighted, right? So for example, I can say that if I want P1 to reach the loopback of P2, right? So for example, in P1, I configure an SRT policy that will say for all the color prefix with 100 that has the endpoint 2.2.2.2, I would have an explicit path going through P1, then provider 1, then P2, and here I will assign a weight of 50, for example. And the other path that I want to load balance the traffic towards this destination will be from P1 to provider 2, then to PE2. And here I will assign a weight of, let's say, 90, right? So basically here, for all the prefixes that are colored with the color 100, right, pointing to the same destination, I will have two paths going through first P1, provider 1, and then provider H2. Then we will have the second path that will go from provider H1 to provider 2, and then finally to PE2, right? So this, in a nutshell, the configuration that we will do, right? Here I can say instead of 90, for example, I can put 50, right? If I want to distribute the traffic equally. So how the maths works here, basically, the maths is simple. So how I know how much traffic will go upper and how much traffic will go downstream. So basically what I need to do is, the mathematics works like that. So for example, I want to calculate how much percentage of the traffic flow will go through the first path. So I need to put 50, which is the weight of the first path, divided by the sum up of both of them. So it's 100. So this is 1, 2, so 0.5, so it's equal to 50% of the traffic will go to the first path, and since the second one has the same 50, then the other 50% of the traffic will go to the second explicit path. Basically, that's it, right? If you have different values, then you need to do the math to more or less estimate how much traffic flow will go through each of these explicit paths, right? In my case, I will do a simple lab where I will configure a weight of 50 and 50. So essentially, there should be traffic balancing across these two paths. So obviously, this is a lab environment. We don't have too many traffic flows. So probably we will not see the load balancing across them. But in fact, we will see in the policy that these two paths has been created and that the traffic is at least, if we put, for example, in P1, if we go to P1 and type show Ceph for the prefix of C2, that is 200/32, if we put inside of this BRF show Ceph BRF, let's say X 200/32, we will see that this is pointing to the policy that we will create or that we already have. And then inside of the policy, when we type the command show segment routing traffic engineering policy name and the name of the policy, we will see these two paths active. And that's basically the meaning that these two paths are working, and this is basically we distribute the traffic based on the weight that we have configured. And this is in a nutshell segment routing, traffic engineering, weight, ECMP, the way that we can do load balancing across SRT. Okay, so let's go through the lab. Basically, we will do exactly what I have configured here in this note here. So we'll go through P1. In P1, I already have the first policy. So this one here, I already have. And this is the one that we configured in the previous video. So basically, we created a segment list, listing the labeling for going through from P1 to provider 1 and then to provider H2. So this is already done. I already have the SRT configuration. I already have the coloring as well. What I don't have is the second explicit path, and also I don't have the weight in each of them. So what we will do is basically configure the second explicit path in the P1 to go through provider H2 and then to provider 2, sorry, and then to provider H2, and then we will configure the weight, and we will do some verification command as well, right? So let's go through the device line. I'll just remove all the nodes here. So if I go, for example, to, in this case, I will go through P1. So here I have already, as I said, the first segment list, so it's an explicit path. I remember here that I always mention explicit path, but actually when you configure a segment list, it's just the way that we learn it in MPLS traffic engineering. We always configure explicit path name, and that's why I mention a lot of explicit path. So we already have the first segment list. What I will do is configure the second one, and I will tell P1 that the second one will go through provider 2 and then finally to provider H2. Please remember, this is provider H2. I always forgot to change the image here. So let's go through it. Actually, what I will do is I will create the path based on the addressing. Here, the first explicit path is made by labels, based on labels. So what I will do is we'll create a second explicit path based on the addressing. So I will put here P1 to provider H2, then to provider 2, then to provider H2, index 10, address IPv4 10.1.2. So this is the IP address of the interface of provider 2, this one here. So let's configure that, and then I will configure provider index 20, sorry, addressing IPv4, and then here the loopback of PE2, right? So with that, I already will have the second explicit path, right? So I'll just configure it, commit, we'll see show configuration segment routing. Then what I have done is, again, I just configure the second explicit path from going from provider H1 to provider 2 and then to provider H2, right? This is based on addressing and this is based on labeling, okay? So as you can see here, I already have the policy from P1 to P2, right? The color is 100. The endpoint obviously is a loopback of PH2. I already have the preference, a 100. This is very important. I will not configure a second preference. I will put the two explicit paths under the same preference. Because if I configure another preference, this preference will be preferred if it's higher. And then we will not have the load balancing, right? So that's why the explicit path should be in the same preference if we want to have a load balancing across different paths. So oh, sorry for that. So here we have already a weight, which I will change to 50, right? So let me just first attach this explicit path I already created into this policy. So I will put here candidates preference 100. Then I will put explicit segment list P1 to provider H2, sorry, to provider 2 to provider H2. I will put here weight of 50. So as you can see, I created a explicit segment list from P1 to provider 2 to PH2, and then I will put explicit, I will configure the same weight for the PH1 to provider 1 to provider H2. So it's the upper path. So I will configure just the same weight. Okay. So I have to go to explicit paths, segment list P1, PH2, and here weight 50. So now my configuration is done. Show commit. Let's see what we have. So here we have what we mentioned, right? So we have two explicit paths under the same preference, and we are pointing to the same next hop. So this is what we were explaining in the beginning, right? So we point to the same next hop, but we are going through two different paths in the core, and we are configuring the weight of 50 in each of them, meaning that we will load balance the traffic more or less equal, right? So what I can do to verify this? Show segment routing traffic engineering policy name, my policy name. This is a command that you can use for verify any of your segment routing traffic engineering policies, okay? So then we type enter, and then we can see here that both of them are active, right? So we have the preference 100. First, this is our policy, which is up. This points to the PE2. I will just expand this a bit more for having a bit more of content. So here under the preference 100, we have the two explicit paths, one going to the upper part of our network here, basically, and the other is going through the lower path. And both of them are active, and the weight for both of them is 50, meaning that the traffic will be more or less equally load balanced. So if I try, for example, show Ceph under my VPN, blue 200, 200, 200, then here again we see the binding seat, and we see that in the P1 pointing to this service IP addressing, we are going to this policy that basically is this one that is up, and the traffic will be balanced across both of them. By the way, if I didn't explain, here in my network I have a BRF here that is BRF blue VPN, and the same here is exactly the same blue VPN, right? Oh, sorry for the, and here I have two loopbacks, 200/32 and 201/32, and here I have two loopbacks, 100/32 and 101/32. This is BGP, this is BGP, this is BGP before with the raw reflector, right? So this is more or less my network, right? So for example, if I go to this, well, before going through the CE, this basically shows us that the policy is perfectly inserted into the FIP, into Ceph, and is perfectly pointing to the policy. And it should do a load balancing across these two paths, right? Now, my network is a lab environment. It's a virtual environment. I don't have too many traffic flows. So probably we will not see different paths going cross. So what we will try to do is we will just try a trace route from C1 loopback 100 to C2 loopback 100. We will try a trace route across them, and the same here from P1 loopback 101 to loopback 201 in C2. Sorry, from C1 loopback 101 to C2 loopback 201. We'll try a trace route between them, and we'll see if the traffic goes upper or down, right? So this upper is the link 110.110, and here's 10.120, right? So this is more or less the addressing across them. So let's go to the C1. Here I will do a trace route 100 to the 200, 200, source loopback 0 numeric. So here the traffic is going to the upper part, right? So if I do trace route 201, 201, 201, 200 source loopback 1, that is the loopback 101 numeric, well, it's still going through the upper layer part, but yeah, I mean, this is not a real network environment. So if we have many traffic flows, the traffic more or less should go load balance. And the most important here is that we see that both of the paths are active and is perfectly working, and the weight is actually configured to be equally load balancing. So that's it about weight ECMP. It's very, as you can see, it's very easy to configure. It's very easy to calculate more or less how much traffic or flows will go forward into one explicit path or to the other. It's very simple. It's very practical. It's a way that we can do load balancing SRT. Thanks very much for watching. I hope that it has been very useful for you. Leave the comments if you have any doubts, and yeah, keep it following me. And if you want to see more segment routing videos or more service provider videos. Until the next one. Bye bye.